Hi guys, welcome to this easy maths video. Today we are looking at my predictions for the Edexcel GCSE Maths 2019 paper 3 higher tier. I'm feeling a bit more hopeful that the topics in this paper will reflect the kind of questions that will come up in your actual exam, because there's a handful of topics that we haven't seen come up in paper 1 or paper 2, and they all pretty much manage to fit into one paper. So let's get on to the first question. Question 1, we're told P has coordinates 1, 2, Q has coordinates 7, 10. We've got to find the midpoint of the line PQ. So to find the coordinates of the midpoint, what we do is we add the x values. So we can have 7 plus 1, which is 8, divide that by 2, we get 4 for our x value. And then for our y values, it's going to be 2 plus 10, which is 12. Divide 12 by 2, we get 6. So our midpoint has the coordinates 4, 6. Part B says find the exact length of the line PQ. Okay, so what we need to do for this is we need to work out how many units we've moved parallel to the x-axis and how many units we've moved parallel to the y-axis. So what's going to happen is there's going to be a right angle here because the x-axis is obviously perpendicular to the y-axis. And if we start at the coordinate 1, 2, and we need to get to the x-coordinate of 7, that means we go 6 units across. And then if we start at the y-coordinate of 2, and we need to get up to the y-coordinate of 10, that means we go up 8 units. Now, this is a right angle triangle. We know 2 of the sides, but we don't know the length of the longest side, and that's what we're trying to work out. So this is really just a Pythagoras question. So what we can say is we can use Pythagoras' theorem, which is a equals the square root of b squared plus c squared. So if we say a is PQ, then we're saying PQ is the square root of 6 squared plus 8 squared. And if you type that in onto your calculator, you should get an answer of 10. Question 2 says expand and simplify 2x all multiplied by 3x plus y minus 5x all multiplied by 3x minus 2y. Okay, so let's expand each of these brackets separately. So we've got 2x multiplied by 3x plus y minus 5x multiplied by 3x minus 2y. Okay, so first we're going to multiply the 2x by the 3x, so we get 6x squared. Then we're going to multiply the 2x by the y, so we get plus 2xy. So that's it for that bracket. And then the second bracket, we're going to have minus 5x times 3, so that's minus 15x squared, and then minus 5x times minus 2y, which is going to be plus 10xy. Now we can simplify this. We've got 6x squared minus 15x squared, which is minus 9x squared, and then we've got 2xy plus 10xy, which is plus 12xy. So minus 9x squared plus 12xy is our final answer. Question 3 says the diagram below shows a region that can be represented by 3 inequalities. One is y is less than or equal to 2. Write down the other 2 inequalities that define this region. So first we need to find which line represents the inequality y is less than or equal to 2. We should easily be able to see that it is this line here. Because it's an inequality, so we're saying it's y is less than or equal to 2, we've got a strict inequality, so that means we've got a bold line, and then we're looking at all the y values that are less than or equal to 2. So that's going to be all the values of y that are below the line of y equals 2. So that must be this line here. So we've got to work out the inequalities for these other 2 lines. So let's start off with this line here. Now with this line, it's a line that doesn't pass through the origin. So the equation of our line is going to be in the form of y equals mx plus c, where m is the gradient and c is the y-intercept. Well, you can see from this graph the y-intercept is -3. So c is going to be -3, so we can say y equals mx minus 3. Now the gradient we need to work out by doing the change in y divided by the change in x. So if we take 2 points, let's take the point where it intersects the y-axis and the point where it intersects the x-axis. So that's here and here. Now it's quite hard to see on this diagram because the axes are quite small, but we should be able to see that the line passes exactly halfway between 1 and 2. So we can say that that is the point 1.5. Now we know that this has a y value of -3. So what we're saying is, parallel to the x-axis, we're going 1.5 units along, and then parallel to the y-axis, we're going up by 3 units. So the gradient, if the gradient is the change in y divided by the change in x, and we're just doing 3 divided by 1.5, well, 3 divided by 1.5 is 2. The line is actually going to have the equation of y equals 2x minus 3. Now, we've got to figure out which way the inequality sign will be going. Now, if we look at the region which is shaded, we should be able to see that all of the y values within that region and above the whole of the line y equals 2x minus 3 are greater than the y value where the line y equals 2x minus 3 intersects the y-axis. Well, that's at the point -3, isn't it? So, what that means is the inequality must be y is greater than or equal to 2x minus 3. Now, if we have a look at this second line, it intersects the x-axis at -1 here, and it intersects the y-axis at -1 here. So what's happening is we're going down by 1 unit and we're going across by 1 unit. So this is -1, this is +1. So it's going to be -1 divided by 1, so the gradient is -1. And it intersects the y-axis at -1. So the equation of our line is going to be y equals -x minus 1. But of course we've got to decide which way the inequality sign goes. So again, similar to the line y is greater than or equal to 2x minus 3, we should be able to see that all of the y values above the line of y equals -x minus 1 are all greater than the point at which that line intersects the y-axis, which is the point y equals -1. So therefore, we can say that y is greater than or equal to -x minus 1. That is question 3. Question 4. 3 companies sell the same type of furniture. The price of the furniture from Company A is £1,480. The price of the furniture from Company B is €1,980. The price of the furniture from Company C is $2,250. The exchange rates are £1 equals €1.34 and £1 equals $1.52. Which company sells the furniture at the lowest price? You must show how you get to your answer. Okay, because we've got 2 exchange rates in terms of pounds, so we're going from pounds to euros and pounds to dollars, what I'm going to do is I'm going to convert the prices of the furniture from each of the companies into pounds. So the British pound is going to be our common currency. So if we have Company A, Company A is nice and straightforward because they're selling the furniture at 1,480, so we don't need to use our exchange rates. Now, Company B, the price of their furniture is €1,980. Well, if we know that £1 is equal to €1.34, then we're saying how many pounds is €1,980 worth? So in order to work that out, we need to do 1,980 divided by 1.34 on our calculator, and you should get an answer of £1,477.61 to 2 decimal places. Now, if we have a look at Company C, Well, company C is selling their furniture in dollars. So we know that the exchange rate is £1 equals $1.52. And we want to work out what $2,250 is in pounds. So we need to do 2,250 divided by $1.52, and that gives us an answer of 1,480 £26 to 2 decimal places. And the question says, which company sells the furniture at the lowest price? Well, the answer in this case is company B. So we can just write a little comment saying company B sells the furniture at the lowest price. So our final answer is company B. Question 5. A, B, C, D, E and E, H, J, K, L are regular pentagons. AEL is an equilateral triangle. Work out the size of angle DEH. So we need to work out this angle here, DEH, and if I mark that as X. Now what that means is we're going to need to find what one of the interior angles is in the pentagon ABCDE, and that means that pentagon EHJKL is going to have interior angles of the same value. And then we need to work out what this interior angle here is within the equilateral triangle. And then we know that all of these angles add up to 360, and using that information we should be able to work out what that angle X is. So to work out the interior angle of one of these pentagons, we're going to work out the exterior angle first. So the way we do that is we know that the sum of all the exterior angles of any polygon always add up to 360 degrees. So we're going to have 360, and then we're going to divide that by 5 because a pentagon has 5 sides. So if you work that out, you should get an answer of 72 degrees. So this is the exterior angle for A, B, C, D, E and E, H, J, K, L. They are congruent pentagons. So to work out the interior angle, what we should know is that the sum of the interior angle and the exterior angle add up to 180 degrees. So we know what the value of the exterior angle is. We can do 180 minus 72, which gives us 108, to work out the interior angle for A, B, C, D, E and E, H, J, K, L. So that's 108. That's 108. Now to work out the interior angles for the equilateral triangle, that's easy. That's just 180 divided by 3, which is 60. So that is the interior angle of AEL. So that was 60. So now we know all of the angles in this circle, if you like. So they all add up to 360 degrees. So we can say that the angle DEH be equal to 360 minus 108 minus 60 minus 108. So if we work that out, you should get an answer of 84 degrees. So question 6 says the normal price of a television is reduced by 22.5% in a sale. The sale price of the television is £430. Work out the normal price of the television correct to the nearest pound. Okay, so we know that the normal price represents 100% of the price of the television. We know what the sale price is. So the sale price is when television is reduced by 22.5%. So that means the sale price is going to be 100 minus 22.5, which is 77.5%. So the sale price is 77.5% of the normal price. And we know what that is equal to. It's equal to £430. So we need to work out the normal price, which is 100% of this value here, 430. So what we can do is we can work out 1%. So 1% is going to be doing, we need to do 430 divided by 77.5. So we get 5.54838797. And then to work out 100%, we're just going to multiply it by 100. So we get £554.8387. So to the nearest pound, that's going to be £555. So that is our final answer for question 6. Question 7 says Toby invested £4,500 for 3 years in a savings account. He was paid 4% per annum compound interest. How much did Toby have in his savings account after 3 years? So that means we need to do 4,500. Now we're going to increase that amount by 4%, so we're going to multiply it by 1.04. And that's for 3 years, so we raise it to the power of 3. So if you work that out on your calculator, you should get an answer of £5,061.888. So that is our final answer for part A. Second part says Jasper invested £2,400 for n years in a savings account. He was paid 7.5% per annum compound interest. After n years, he had £3,445.51p in his savings account. Work out the value of n. Okay, so the first thing we need to do is we need to form an equation similar to what we did in the first part. So he invests £2,400. He gets 7.5% compound interest per year, so that we're going to multiply that by 1.075. Now, after n years, he gets £3,445.51. So, rather than trying to solve this equation for n, what I'm going to do is I'm going to plug values into this equation. So we're going to have n equals 1, n equals 2, n equals 3, and so on. So if you do 2,400 times 1.075, you get 2,580. So when n equals 1, you get a value of 2,580. So that's not right because we're looking for the value of £3,445.51. So we raise 1.075 to the power of 2. We can say when n equals 2, we get a value of £2,773.50. And then when n is 3, we get £2,981 and then 5125. And then when n is 4, we get £3,205.125938. We're getting closer, so when n is 5, we get £3,445.51. Rounded that to 2 decimal places, but that's what we were told that Jasper accumulates at the end of n years in his savings account. So the answer must be n equals 5. Question 8 says show that the recurring decimal 3.142 can be written as that mixed number in its simplest form. So for these questions, we introduce a variable. We call that variable x. So we're going to say let x, where the 2 is recurring, and we can say that that is the same as saying 3.14 and then just repeating the 2's. And of course they're going to repeat infinitely. Now we want to try and get rid of all of these 2's. So we need to find some multiple which we can multiply both sides of this expression by in order to cancel out those 2's. The easiest way to do this is to use multiples of 10. So if we multiplied both sides of this by 10, we're going to get 10x equals 31.4, and then all of the 2's are going to keep recurring. But there you should be able to see that they're not going to be able to cancel out properly. So what we need to do is we need to have all of our values of 2, the recurring decimal of 2, after the decimal point. And the way we can do that is we can multiply both sides of this expression by 100. So we can say 100x equals, that's going to be 314.2222222, and so on. And now, if we call this one 1 and this one 2, if we do 1 subtract 2, we're going to get 100x minus x, which is 99x. Now, and if we start subtracting these from the right hand side, you should be able to see that all of these 2's are going to cancel. Well, here we're just doing 22 minus 14, which is 8. So we're going to have an 8 here, and a 0 here. And then we're going to have 314 minus 3, which is 311. So now we can rearrange this, 99x equals 311.08, to get what our value of x is. So if we divide both sides by 99, we're going to get x equals 311.08 divided by 99. So if you work that out on your calculator, you should get an equivalent fraction of 707 over 225. So now we need to write this as a mixed number. So we need to work out how many times does 225 go into 707. Well, by looking at this mixed number here, it should go, 225 should go into 707 3 times. So if you do 225 times 3, you get 675. So we can say it goes in 3 times. Now we need to work out what the remainder is out of 225. So if we do 707 minus 675, that gives us 32 as our remainder out of our denominator, which is 225. So therefore, we have shown that this is our final answer. Question 9 says the diagram shows a solid cylinder. The cylinder is made from tungsten. The density of tungsten is 19.25 grams per centimeters cubed. We got to calculate the mass of the cylinder. Give your answer correct to the nearest gram. So our formula which connects mass, density and volume is mass equals density times volume. Now we know what the density is, that's 19.25 grams per centimeter cubed, but we don't know what the volume of this cylinder is, so we're going to have to work that out. So the formula for the volume of a cylinder is pi r squared multiplied by the height. So we know what the diameter of this cylinder is, that's 10 centimeters. So to work out the radius, that's going to be 5 centimeters. So the volume is going to be pi multiplied by 5 squared times the height, which is 12. If you simplify that, we're doing 25 times 12 times pi, so we get 300 pi. And then the mass It's going to be 19.25 times 300 pi. That gives us 5,775 pi, but we want to round this to the nearest gram. So we get 18,142.70. That's to 2 decimal places. So to the nearest gram, that's going to be 18,143. So that is our final answer. Question 10 says solve the following equation, give your answer to 2 decimal places. We've got 4x squared minus 6x plus 1 equals 0. Well now, if I try to factorise this by inspection, I know that 1 only has factors of itself. So this isn't really going to be that easy to do by inspection. So if I know that I have to give my answers to 2 decimal places, that means I'm going to have to use the quadratic formula. Quadratic equations are always expressed as ax squared plus bx plus c, where a, b, and c are our coefficients. So in this case, a is going to be equal to 4, b is going to be equal to minus 6, and c is going to be equal to 1. So the quadratic formula that you should know off by heart is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So now I just need to substitute these values of a, b and c into this formula. So we're going to get x equals, we're going to have 2 negatives here, and then plus or minus square root of minus 6 squared minus 4 times 4 times 1 all over 2 times 4. Now, because of that plus or minus, we're going to have 2 values of x. So the best thing to do is simplify the numerator first. So we've got these 2 negatives, so that's going to be positive 6, then plus. Now, if you type in the square root, minus 6 squared minus 4 times 1 into your calculator, that's going to simplify to 2 root 5. And then our numerator is just going to be 2 times 4, which is 8. So that means our other x value is going to be the exact same as our first x value. We're just going to replace plus with minus. So we're going to have 6 minus 2 root 5 over 8. Now, if we work out these values of x on our calculator, we're going to get 1.31 to 2 decimal places. And if we work out that second value of x, we're going to get 0.19 to 2 decimal places. So x equals 0.19 or x equals 1.31. That is our final answer for question 10. Question 11 says the nth term of a sequence is given by an squared plus bn, where a and b are integers. The second term of the sequence is 4. The fourth term of the sequence is 32. Find the sixth term of the sequence. Okay, so in order to find the sixth term of the sequence, first we need to work out what the nth term is. So we know that it's in the form of an squared plus bn, but we don't know what those values of a and b are. So we're going to have to work those out first. And we can do that by using the information that we've been given in the question. So it says that the second term of the sequence is 4. So what that means is if we take an squared plus bn and substitute 2 into that formula, that should be equal to 4 because it's the second term in the sequence and it outputs a value of 4. So we're going to have a multiplied by 2 squared plus b multiplied by 2, and that equals 4. So if I simplify that, I'm going to get 4a plus 2b equals 4. Now, if I do the same for the fourth term, so that's going to be a multiplied by 4 squared plus b multiplied by 4, and that all equals 32. So if I simplify that, I'm going to get 16a plus 4b equals 32. Now you should be able to see here that I've got two different equations in terms of a and b. So what that means is I'm going to have to solve these simultaneously in order to work out my values of a and b. So if I call this equation 1 and this equation 2, then what I can do is I can multiply equation 1 by 2. So I'm going to get 8a plus 4b equals 8. And what that allows me to do is that allows me to cancel out those b's, because I've got two equations which include 4b. So the first equation is 8a plus 4b equals 8. And the second equation is 16a plus 4b equals 32. And what I can do is I can take the second equation and subtract it from the first equation. So if I do 16a subtract 8a, I'm going to get 8a. Subtract 4b from 4b, I'm going to get nothing. And then if I do 32 minus 8, I'm going to get 24. So now I can divide both sides by 8. So I get a equals 24 over 8, which is 3. So that's my value for a. Now to work out my value for b, I just need to take any of these two equations and rearrange it to make b the subject of my formula. So if I take this first equation here, 4a plus 2b equals 4, as it's probably the easiest to rearrange, I can then subtract 4a from both sides and divide by 2. So I'm going to get b equals 4 minus 4a all divided by 2. And of course that just simplifies to 2 minus 2a. So now if I replace a with 3, I'm going to get 2 minus 2 all multiplied by 3. 2 minus 6, which is minus 4. So now I've got a value of a which is 3, a value of b which is minus 4. So now I can rewrite my nth term of the sequence. So it's going to be 3n squared minus 4n. Now we're not finished because the question said we need to find the sixth term of the sequence. So that means we need to substitute 6 into our nth term formula. So we're going to do 3, place n with 6, so we're going to have multiplied by 6 squared minus 4 multiplied by 6. If we simplify this on our calculator, you should get an answer of 84. And that's part A. Now part 2 says here are the first 5 terms of a different quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Okay, so if I write out this sequence again, I'm going to try and find the common difference. So this is going up by 4, then by 6, then by 8, and then by 10. So we actually have a second difference here because it's a quadratic sequence. So the common difference here is going to be increasing by 2. So now what we can do is we can use our formulas for working out the nth term of a quadratic sequence. So the three formulas are a plus b plus c, which is the first term of the sequence. Then the second equation is 3a plus b, which represents the first difference. And then the second equation is 2a, which represents the second difference. Okay, so if we start off with the second difference, we know that 2a is equal to 2, so we can solve for a, because we just need to divide both sides by 2, so we get a as 1. And of course our quadratic sequence is going to be in the form of an squared plus bn plus c. So now we've got a value for a, we can use 3a plus b, and we can set that equal to the first difference to work out b. So we're going to have 3 multiplied by 1 plus b, and that equals 4. So we get b equals 4 minus 3, and that is 1. Now, and if we use a plus b plus c is equal to the first term, that's going to be 1 plus 1 plus c equals 2. Well, that's just going to make c equal to 0. So now, if we substitute our values of a, b, and c into the general formula for a quadratic equation, we're going to get n squared plus n. And that's it, because we don't have a value for c. So that is our quadratic expression. Question 12, we've got the equation x cubed plus 4x equals 1. Part A says show that the equation above has a solution between x equals 0 and x equals 1. So what I'm going to do is I'm going to rearrange this equation slightly. So I'm just going to bring the 1 over to the left hand side. So we're going to have x cubed plus 4x minus 1 equals 0. Now, because this equation now equals 0, basically working out our x values for when the y values of this equation are equal to 0. So what should happen is when I substitute both of these values into this equation, if I end up getting a sign change, so it either goes from negative to positive or positive to negative, then what that means is I'm getting closer to a solution to this equation, and that means I'm getting closer to when y is equal to 0. So if we substitute x equals 0, so that's easy, we're just going to get minus 1, but when x is 1, we're going to get 1 cubed plus 4 times 1 is 5, 5 minus 1 is 4. So what we can say is, as there is a sign change from negative to positive, the equation must have a solution between x equals 0 and x equals 1. Part B says show that the equation above can be rearranged into an that should say iterative, not iterative, formula. Then using your formula, starting with x equals 0, find an estimate to the solution of the equation above. When trying to work out what our iterative formula is going to be, we're going to have two different values for x. We're going to have x of n, which is going to be our nth value of x, but then we're also going to have the term after that, which is x of n plus 1. And what that allows us to do is we can work out what x of n plus 1 is in terms of x of n. So this is the formula we're working with, x cubed plus 4x equals 1. Because what I want to do is I want to rearrange this so that I make x of n plus 1 our subject. So I want to make this as easy as possible for me to rearrange. So what I'm going to do is I'm going to make x cubed x of n, so it's x of n cubed, and then plus 4x of n plus 1, and that's equal to 1. So now I can rearrange this equation to make x of n plus 1 a subject. So if I minus x of n cubed from both sides, I'm going to get 4x of n plus 1 equals 1 minus x of n cubed. And then I can just divide both sides of my equation by 4, so I get x of n plus 1 equals 1 minus x of n cubed all over 4. So that's our formula, which we had to rearrange. Then using this formula, starting with our initial value of x equal to 0, we need to find an estimate to the solution of the equation. So what you can now do is you can type this equation into your calculator. So you're going to have 1 minus, and replace x of n with answer. So we're going to set answer equal to our initial value of x, which is 0. So I'm going to say 0 equals, and I'm going to do 1 minus answer cubed, all divided by 4. Okay, and if you press equals for your first value of x, you should get a quarter, which is 0.25. If we select equals again, we get x equals 0.24609.375. That keeps on going. And if we select it again, we're going to get 0.246274093. That keeps on going. And what you would do is you would keep writing down each of these values of x until the value of x doesn't change, because what that means is our sequence has now converged. We've now got one constant value for x. So you can keep pressing the equals button, and you should find that our final value of x is going to be 0.246661722. And that is our final answer. Question 13 says a road is 4,530 metres long, correct to the nearest 10 metres. Kirsty drove along the road in 205 seconds, correct to the nearest 5 seconds. The average speed limit for the road is 80 kilometres per hour. Could Kirsty's average speed have been greater than 80 kilometres per hour? You must show your working, and your final answer should be correct to 2 decimal places. Okay, so we're given a distance and we're given a time, so we can work out the speed using the formula distance equals speed times time. So we can rearrange this to get the speed. So speed is distance over time. Now, we're trying to see whether her average speed can be greater than 80 kilometers per hour. So we're trying to find the maximum speed that she can basically travel at based on this distance to the nearest 10 meters and this time to the nearest 5 seconds. So what we're doing in this case is we're actually working out the upper bound for the speed. Now, because speed is represented by one variable divided by another variable, what we're saying is to work out the upper bound, we need to take the upper bound of the distance and divide it by the lower bound of the time. And the reason for that is because obviously if you're dividing two numbers, you want your numerator to be as large as possible and you want your denominator to be as small as possible. So that's the reason why we're doing the upper bound divided by the lower bound to find our maximum value for the speed. So that means we need to work out what the upper bound for the distance is. So the distance equals 4,530 meters. Now that's to the nearest 10 meters. So if we look at each digit, we're looking at the units, the tens, the hundreds, and the thousands. So we're told that this is rounded to the nearest 10 meters. So if we take 10 meters and divide that by 2, we get 5. So what that means is we're going to add 5 to our distance to work out our upper bound, and we're going to subtract 5 from this distance to work out our lower bound. So that means our upper bound equals 4,535, and our lower bound is 4,525. Then we can do the same for the time. So the time is 205 seconds, and that's correct to the nearest 5 seconds. So nearest 5 seconds is this value here. So we can take 5, divide it by 2, and we get 2.5. So what that means is we're going to add 2.5 to get our upper bound, and we're going to subtract 2.5 to get our lower bound. So our upper bound is 207.5, and our lower bound is 202.5. So our speed we're going to take the upper bound of the distance, which is 4,535, and divide it by the lower bound of the time, which is 202.5. So it's 4,535 divided by 202.5. So we get 1,814 over 81. So now that's an equivalent fraction for the speed. So what we're saying is we've travelled a distance of 1,814 metres. It's taken us 81 seconds. But we've got to be a little bit careful because our average speed is in kilometres per hour. So we're saying that the distance is in metres, but we actually need to convert that to kilometres, and our time is in seconds, and that actually needs to be converted to hours. We know that 1,814 metres is going to be 1.814 kilometres. Now, to work out 81 seconds in hours, we should know that there's 3,600 seconds in an hour. So, if we do 81 divided by 3,600, we get 0.0225. That's going to be our hours. So, our speed is now going to be, if I just move this over slightly, our speed is going to be 1.814 divided by 0.0225. Now we get a value of 80.62 to 2 decimal places, which is what the question asks for, and that's kilometres per hour. So is 80.62 greater than 80 kilometres per hour? Yes, it is. So that's our final answer, but we need to write a short statement saying that her average speed can be greater than 80 kilometres per hour. So we can say that Kirsty's average speed can reach 80.62 kilometers per hour, which is greater than 80 kilometers per hour. And that's question 13. Question 14 says ABCD is a rhombus. M and N are points on BD such that DN equals MB. Prove that triangle DNC is congruent to BMC. Okay, so what I'm trying to do is I'm looking at this triangle here, and this triangle here, and I'm trying to prove that they're both congruent to each other. So I think the most obvious point to make, because we're told it in the question, is that this length DN is equal to this length MB. So we can say as DN equals MB, the side lengths are both equal. Now, the other side that we can explain is this side down here. So if I represent that with 2 dashed lines, well, because we know ABCD is a rhombus, and you should know that all of the sides of a rhombus are equal, we can therefore say that DC is equal to CB. So that shows that they're congruent. So as ABCD is a rhombus, this means all of the side lengths are equal. Therefore, DC equals CB. So we've looked at 2 of the sides. So what I'm going to do is I'm actually going to look at an angle now. So we're using the rule of SAS, which is side angle side. And the angle we can actually look at is this angle here and this angle here. You should be able to see that they are equal because we've proven that DC is equal to CB, and if we've got this triangle DCB and we've got two lengths which are equal, that means we've got an isosceles triangle. So we can say, as the triangle DCB is isosceles, as DC equals CB, so we can say therefore the two base angles of the triangle must be equal. So the angle BDC is equal to the angle DBC. So we've looked at two sides of each of the triangles, and we've looked at an angle within each of the triangles. So therefore, we've proven that the two triangles are congruent by SAS. So that is our final answer for 14. Question 15 says, this table gives information about the height h of some slides at a water park. We've got to draw a histogram to show this information. Okay, so when you're drawing a histogram, on our y-axis, we have our frequency density, and on our x-axis, we've got our height, which is represented by h meters. So in this table, we're given the height and the frequency, but we need to work out what the frequency density is. So you should know the formula for frequency density is the class width divided by the frequency. So the class width is just the distance between each of these heights. So the class width between 0 and 2 would be 2. So what I'm going to do is I'm going to add another column for frequency density, and we're going to work out the frequency density for each of these bits of data. So the class width for the first one is 2, and the frequency is 5. So we're going to do 2 divided by 5, which is 0.4. Then the next one, the class width is 2, and we're dividing that by a frequency of 10, so we're going to get 0.2 for the frequency density. The next one, the class width is going to be 12 minus 4, which is 8, divided by the frequency, which is 24. And we get a third for that, so what I'm going to do is I'm going to round that to 2 decimal places, so we get 0.33. And then for the next one, we've got a class width of 4, because 16 minus 12 is 4, and then we're going to divide that by a frequency of 20. So 4 over 20 is 1/5, which is 0.2. And then for the last one, we've got a class width of 20 minus 16, which is 4, divided by a frequency of 18. So we get 2/9 for that, which is 0.22 to 2 decimal places. So now we need to plot the information on our grid. So we're going to plot the height against frequency density. So if I draw my scale for the frequency density, what I'm going to say is for every 10 small squares, so that's going to represent a frequency density of 0.1. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 0.1, and then we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 0.2. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 0.3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 0.4. Okay, so that fits on nicely. And then for the heights, I'm going to say that every 5 squares represents a distance of 2 meters. So we're going to 1, 2, 3, 4, 5, so that's going to be 2. And then we go from 0 to 2 to 2 to 4, so the next 5 squares. So that's going to be 1, 2, 3, 4, 5, so we're going to 4 there. Then we're going from 4 to 12. So we're actually going distance of 8 meters rather than 2 meters. So if every 2 meters is 5, then for every 8 meters it's going to be 4 times that amount. So we're going to go across 20 squares. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 there. So that is 12. And then we're going from 12 to 16, so that's 4. It's a distance of 4. So we're going to go across 10 squares. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then another distance of 4 meters, so we're going to go across another 10 squares. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20 is there. And yeah, that works out about right. So now we just need to draw our bars. So the first one is going to have frequency density of 0.4 and a height of 2 meters. So that is going to look something like that. And then the next one is going to have a height of 2 meters and a frequency density of 0.2. So that's going to be like that. And then the next one has a height of 8 meters and a frequency density of 0.33. So 0.33 bring us up to here. If I do the same for this one, okay, so that's there, and then I can just connect these. And then the next one has a height of 4 meters and a frequency density of 0.2. So 0.2 is going to take us up to here. And then we can connect these two. And then the next one has a height of 4 meters and a frequency density of 0.22. So that one is actually going to bring us up to there. So that is what our histogram looks like. So if I shade that in, that is what our histogram looks like. Question 16 says solve the simultaneous equations x squared plus y squared equals 20 and 3x equals 2 minus y. So our first equation is x squared plus y squared equals 20, and our second equation, now for our second equation I'm going to rearrange it so we've got y as our subject. So that means we can have y equals 2 minus 3x if we rearrange that. So now what I can do is I can substitute 2 minus 3x into x squared plus y squared equals 20. So I'm just replacing y with 2 minus 3x. So that's going to be x squared plus 2 minus 3x all squared equals 20. Then if I expand this bracket, still going to be equal to 20, so we're going to have x squared, and we're going to have plus 2 times 2 is 4, and 2 times minus 3x is minus 6x, minus 3x times 2 is minus 6x, and then minus 3x times minus 3x is plus 9x squared, and that all equals 20. So if I simplify the left hand side, I'm going to get 10x squared minus 12x plus 4, and that equals 20. Subtract 20 from both sides, we get 10x squared minus 12x minus 16 equals 0. Then I can divide through by 2, so divide both sides by 2, I get 5x squared minus 6x minus 8 equals 0. Now we need to find 2 factors of 8, which then I can then either add or subtract to give me this result of minus 6x. So the 2 factors I can think of are 4 and 2. So when we factorise this, we're going to have 5x multiplied by x. Now we've got to think where these factors of 4 and 2 are going to go. Well, what we want to do is we want to multiply the 2 by the 5 so that we get 10x. So if we make that minus 2, we're going to have minus 10x, and then we can just add the 4x. So that's going to give us minus 6x, and then when we multiply the 4 by the minus 2, we're going to get minus 8. So we can say that this is 5x plus 4, and this is x minus 2, and that's all equal to 0. So now if I solve this, I'm going to get x equals minus 4/5, or x equals 2. So now I can work out my values of y by substituting these values of x into y equals 2 minus 3x. So I'm going to get y equals 2 minus 3 multiplied by minus 4/5. If you work that out on your calculator, you'll get 14/5. And then for the second one, it's going to be y equals 2 minus 3 multiplied by 2. That's going to give us minus 4. So I'm going to write these fractions as decimals. So minus 4/5 we know is minus 0.8. So I'm going to have minus 0.8 for x, or 2. And then for y, well, 14/5 is the same as 2.8. So we're going to have 2.8 or minus 4. And they are our final answers for question 16. Question 17, the graph below is of the function y equals sine x. Part A says write down the coordinates of the point P. So we should know that the sine curve for one complete oscillation is going to be between 0 and 360 degrees. So the second point at which it intersects the x-axis at that point P, we're going to have an x-coordinate of 180 degrees and then a y-coordinate of 0. And then part B says write down the coordinates of the point Q. If I draw a dashed line here and another dashed line here, you should know that the maximum value for y equals sine x is 1 and the minimum value is minus 1. So we know that the y coordinate for Q is going to be minus 1. Now in its x value, well, if P had an x value of 180, and we know that its complete oscillation ends at 360 degrees, then the x value for Q is going to be halfway between 180 and 360. So that is 270. So we're going to have the coordinate 270 minus 1. Now on the part C says on the graph above, draw the function y equals minus sine 2 of x. So we've got sort of two transformations combined here. We've got this negative in front of the sine x, and then instead of sine x, we've got sine 2 of x. If I say that function x is equal to sine x, then when I have function x equals minus sine x, what happens is when I replace a negative in front of my function, it's a reflection in the x-axis. So if I draw that on here in a different colour, let's use red, if I was just drawing y equals minus sine x, I'm just going to reflect the curve from 0 to 180 in the x-axis, so it's going to look something like that. I'm going to reflect the curve from 180 to 360 in the x-axis again. So it would look something like this. So that's the way our curve is going to flow, if you like. We're going to start from 0, and then our values of y are going to be negative, and then when they get past 180 degrees, they're going to become positive, and then it's going to go back through to 360. But we need to see what happens when we replace x with 2x. So what happens is this is a scale factor enlargement. Now let's say I've got function sine of x, but now I'm going to have a new function which is going to be sine a of x. What that means is I'm going to multiply all my x values for sine of x by 1 over a, so it's the reciprocal of a. So in this case, if I've got sine of 2x, it means I'm going to half all my x values. Okay, so if I'm going to half my x values, half of 0 is 0, so it's still going to be going through the point 0, but the next point that sine x goes through is 180, but if we're halving that, the next point it's actually going to go through is 90. And then the next point it goes through after that is 360. And half of 360 is 180, so it's actually going to go through 180 as well. But then we've got to sort of think about the x values past 360. So this oscillation of sine x keeps on repeating. So the next bit at which it intersects the x-axis is 360 plus 180, which is 540. And if you divide that by 2, you get 270. So that's going to be the next point at which it intersects the x-axis. And then after that, when it gets to the end of its oscillation, or its second cycle, it's going to intersect the x-axis at 720. So we halve 720, that's 360. So it's going to go through the points 0, 90, 180, 270, and 360. So if I get rid of this curve here, so our curve should look something like this. And that is our final answer for part C. Question 18, part A says write down the equation of the following graph. Well, we've got a circle here that is centered at the origin. So if it's centered at the origin, it's in the form x squared plus y squared, and that is equal to the radius squared. Well, the radius in this case, starting at the center, it goes from 0 to 3, so it intersects the x-axis at 3, so its radius must be 3. But we have to square that, so we're going to have x squared plus y squared equals 3 squared, which is 9. So that's part A. Now, part B says there is a tangent to the circle at a point T with coordinates 2.55, 1.58. The tangent also intersects the x-axis at a point U. Work out the coordinates of the point U where the value of x is approximated to 3 significant figures. Okay, so what we're doing is we're using this equation for this circle, and we're trying to work out where the tangent at the point 2.55, 1.58 intersects the x-axis. If I draw that on this graph here, that's going to be roughly here, and our tangent is going to look something like that. So at this point here, so this is the point T up here, and this point down here is the point U, so we're trying to work out what the coordinate of U is. Okay, so T had coordinates 2.55, 1.58. So what we're going to need to do is we're going to need to work out the gradient of the tangent. So if we're going from the center, 0, 0, to the point 2.55, 1.58, what's going to happen is we're going along 2.55 units and we're going up by 1.58 units. So the gradient from the center to the point T so the gradient of OT equals the change in y divided by the change in x. So the change in y is 1.58 and the change in x is 2.55. So it's 1.58 divided by 2.55. And that's just the equivalent of 158 over 255. Okay, so the gradient's not too difficult to work out. Now, the reason why we worked out the gradient of OT is because we need to work out the gradient of the tangent. Now, and you should know from your laws of circle theorems that if you've got a tangent touching a circle at a particular point, the tangent line is going to be perpendicular to the line that goes from the center of the circle to the point of the tangent. So that's just the radius of the circle. So there's a right angle here. Now, you should know from equations of lines that if you've got the equation of a line which is perpendicular to another line, then their gradients are going to be the negative reciprocal of each other. So we need to work out what the gradient of the tangent is. So the gradient of the tangent is the negative reciprocal of that. So it's going to be minus 255 over 158. So that's the gradient. Now the equation of the tangent is going to be in the form of y equals mx plus c. So m's the gradient, which is minus 255 over 158, but we need to work out what c is. So we can work out what c is using the point t, which is 2.55, 1.58. So y is going to be 1.58, and that's going to be equal to minus 255 over 158 multiplied by our value of x, which is 2.55. And that's going to be plus c. So if I simplify minus 255 over 158 times 2.55, I get minus 2,601 over 632. So what I can do is I can add that to both sides. So I'm going to get 1.58 plus 2,601 all divided by 632. And that's going to equal c. So if I work out what that is on my calculator, I get c is equal to 5.69550632.9, and that keeps on recurring. Okay, so if I round this up to three significant figures, that's going to be 5.70 for c. So that means the equation of the tangent can now be written as y equals minus 255 over 158 x plus 5.70. So now I need to work out at which point does this equation intersect the x-axis. Well, it intersects the x-axis when y equals 0. So now I can set this equation equal to 0, and then I'm going to solve for x. So what I can do is I can add minus 255 over 158 x to both sides. So I'm going to get 255 over 158 x equals 5.70. And if we solve for x, x is going to be 5.70 times 158 all over 255. If I work that out on my calculator, I get 3.53 to three significant figures, as that's what the question asked us to approximate it to. So point U equals 3.53, and then of course our y coordinate is just 0. So it's 3.53, 0. Question 19 says Dennis cycles 12 miles from town A on a bearing of 55 degrees. His friend Lucy walks from town A for 17 miles on a bearing of 140 degrees. We need to find how far Dennis is from Lucy. Okay, so for this question, we're going to need to use a protractor to draw a diagram of what's going on here. So we've got this town A down here. Okay, and what I'm going to do is I'm going to draw a north line, because we always draw north lines for bearings. We're going at a bearing of 55 degrees. So if you use your protractor, using this north line, 55 degrees is up here. Okay, so what I'm going to do is I'm going to draw a straight line for 12 miles in that direction. Doesn't matter, we don't have a scale, so you can just make 12 miles whatever distance you want. So I'm going to make it look like this, so that's 12 miles, and this angle here, or this bearing rather, is 55 degrees. So if I get rid of that, so Dennis is now here. So Dennis is up here. Now, his friend Lucy walks from town A for 17 miles on a bearing of 140 degrees. So if we measure an angle of 140 degrees from the north line, that's going to be down here. And then if I draw a straight line acting in that direction for 17 miles, then I can say this is 17 miles. This is where Lucy is, and that acts on a bearing of 140 degrees. Okay, so I need to find the distance between Dennis and Lucy. So that is this distance here. So I'm going to call this D. Now, what you should be able to see here is between the 3 points, Town A, Dennis and Lucy, I've got a triangle. I know two of the side lengths of this triangle. I've got a side length of 17 and a side length of 12. Now, and if I had an angle that was opposite my distance, I could work out my distance using the cosine rule. So the cosine rule, remember, is a squared equals b squared plus c squared minus 2bc cos a. Now that angle is the angle A, so it's the angle, in this case it would be the angle opposite D. So we need to work out what this angle is here. Now, that's not too difficult because we know that Dennis cycled from town A on a bearing of 55 degrees and Lucy walked on a bearing of 140 degrees from town A. So we can actually work out this angle because it's just 140 minus 55, which is 85 degrees. So if we replace each of the variables A, B, C, and uppercase A with our values here, then we can work out what D is. So A is going to be replaced by D, so we can have D squared equals 12 squared plus 17 squared minus 2 times 12 times 17, and that's going to be multiplied by cos 85. So if I work that out on my calculator, I'm going to get 12 squared plus 17 squared minus 2 times 12 times 17 cos 85, and that is equal to 834.62566705. So if I square root both sides, I can work out what D is. So we work that out on our calculator. We get an answer of 28.9 miles, and I've rounded that to 3 significant figures. So that is our answer for question 19, 28.9 miles. Question 20 says the Venn diagram below shows the events A, B, and C. We need to find the probability that B intersects not A given C. You need to give your answer as a fraction in the form A over B, where A and B are integers. Now, this is quite a difficult question. So, the first thing to look at, I think, is this probability here. So the probability that B intersects not A, that's what that A dash means. It means not A given C. So what this is conditional probability. So because we've got this given C, that means we're looking at everything within C. Okay, so this is all of C that I've highlighted there. Now, the intersection of B and not A, so B, if I use another highlight, let's use red, so B is all of this. Now, not A, if I use another highlight, I'm going to use green this time, not A is all of this around the outside. So it includes this as well. And it also includes this. So that is not A. Now it's quite hard to see, but the intersection of B and not A given C is this region here where we've got x over 5. So what we're saying is the probability of B intersects not A given C is x over 5. Now it's going to be all divided by our total probabilities for C. So that's 2x squared plus x plus x plus x over 2 plus x over 5. So if I just extend that a bit. Now, of course, the question says that a and b, the values within our fraction, are whole numbers. So we can't have them in terms of x. So what we're going to need to do is we're going to need to find a value for x. Now, this isn't so obvious, but what you should know about probabilities is that all of the probabilities are going to add up to 1. So what you could do is you could generate an equation where you've got all of these x values and it equals 1. And what you'll find is because we've got x squared featured in some of these probabilities, we're going to end up with a quadratic equation. So we're going to add all of the values that we can see and we're going to make it equal to 1. So we're going to have x, and I'm going to tick them off as I go. So we've got x there plus x here. Got another x here, so plus x there. And we've got x over 2 here, so plus x over 2. We've got plus x squared plus 2x. And then we're going to have x over 5, so plus x over 5. Then we're going to have plus 2x squared plus x again, but that's down here. And then we're going to have plus 13x minus 1, so that's down here. Okay, so if I move this across, all of this is now equal to 1. So if I simplify this left-hand side, so if I look at the x squared terms, I'm going to have 3x squared. Now I need to simplify all of the terms which have a coefficient of x. So I'm just going to type that in onto my calculator. So I'm going to have 1 plus 1 plus 1 plus a half plus 2 plus a fifth plus 1 plus 13. Right, and that gives me plus 197 over 10x. And then I've just got minus 1 equals 1. So now I can subtract 1 from both sides to make this equation equal to 0. So I'm going to get 3x squared plus 197x over 10 minus 2 equals 0. And now I want to get rid of this fraction. So I'm going to multiply everything through by 10. So I'm going to get 30x squared plus 197x minus 20 equals 0. Now this does not look easy to factorize, so I would use the quadratic formula in this case. So we know A is 30, we know B is 197, and we know C is minus 20. So using the quadratic formula, which is x equals minus b, so minus 197, plus or minus square root of b squared, so that's 197 squared, minus 4 times a, which is 30, times c, which is minus 20. And that's all divided by 2a, which is 2 times 30. So I'm going to have two values of x here. So like what we did before in the other quadratic question, we are going to simplify this square root first. So we're going to have 197 squared minus 4 times 30 times minus 20, all square rooted. So we get 203. And that's all divided by 2 times 30, which is 60. And our other value of x is going to be minus 197 minus 203, all divided by 60. So if I simplify that first fraction, so minus 197 plus 203 divided by 60, we get 1/10. For the second value of x, we get minus 197 minus 203 over 60, which is minus 20 over 3. Now, this is where we've got to be careful. So, with probabilities, if this Venn diagram just had numbers in it, what we would find is all of those probabilities would be positive. We're not going to have any negative probabilities. And as we can see on this Venn diagram, we've got single values of x. So if we said x was minus 20 over 3, that means we're saying we've got negative probabilities. So that means x cannot be negative. So therefore x must be 1/10. So now we've got 1/10. So now we need to go back to our formula for our probability, and we need to replace x with 1/10. So that's going to be equal to, it's going to get a bit messy this, so we're going to have 1/10. Now, rather than dividing that by 5, I can just multiply that by 1/5. That's going to be all divided by 2 times 1/10 squared plus 1/10 plus 1/10 plus 1/20 plus 1/50. So if you work that out on your calculator, 1/10 times 1/5 all over 2 times 1/10 squared plus 1/10 plus 1/10 plus 1/20 plus 1/50. You should get an answer that the probability of B intersects not A given C is 2 over 29. So A is 2, B is 29. That is our final answer for question 20. And we have now finished the paper.